Hi there. Hope you have a fantastic day today. This lesson, I'm going to teach you rate of change. So let's get into it. So let's say we have a fraction. Let's say we have 2/3. Okay? So 2/3 is exactly the same as 2/3 times 7/7. Right? So this can be written like this, right? 2 and we times 3. So this is 7 and this is 7. So 2/3 is exactly the same as 2/7 times 7/3, right? So therefore, okay, if we have dy dx, so this is the same as dy times dx. And then we can write dt on top. Of course, we can write dt on the bottom. Or if we have dv dt, so this can be written as dv times this is dt, and it can be dr. So this is chain rule. Okay, so please keep that in mind for me. Now let's go through an example. A balloon is being pumped such that its radius expands at 1.2 centimeters per second. What is the rate of change of the volume when the radius of the balloon is 3.8 centimeters? So let's just analyze this a little bit, okay? So we know that the radius is expanding at this rate. So this means that we have dr dt. So expanding, so therefore it's positive. Okay, keep that in mind. So 1.2 centimeters per second. And the question is, what is the rate of change in volume? So that means the question is asking for dv dt. Okay, so that's what the question asks. And when r is equal to 3.8 centimeters. So first of all, okay, we know the questions is asking for dv dt. And we know dv dt is equal to this. So we times this is dt. And because it's given dr dt, so therefore we can just use dr here. There you go. So now we already have the rate of change in radius, dr dt. And now what we need to find is dv dr. And we know that the volume of a balloon, which is a sphere, so which is v, is equal to 4/3 pi r cubed. And we need to find dv dr. Okay, so if we differentiate this, so dv dr, so that will give me the 3, we bring it down, become 3 times 4/3 pi r squared. And we just cancel that. So therefore, the rate of this dv dr is 4 pi r squared. So now we just substitute back to the dv dt. So dv dr is 4 pi r squared. And we times dr dt, in this case, is 1.2 centimeters. So that will give me 4 times 1.2 is 4.8. So pi r squared. So now we have to find the rate of change for the volume at r is equal to 3.8. So let me just move this up. So therefore, okay, dv dt at r is equal to 3.8. Am I right? Yep, 3.8. So just substitute that in. So 4.8 pi times 3.8 squared. So now I just put that in the calculator. So 4.8 shift pi times 3.8 squared. So that will give me 217.75. Okay, correct to 2 decimal place. So that is equal to 217.75. And because it's a rate of a volume, so centimeters cubed per second. There you go. Now, please pause the video and try this one yourself. Hi, I'm back. How do you go? So let me go through it with you, okay, to see whether you got it right or not. But before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, okay, we know that A is given by this. And then we know that the rate of change for B is increasing at the rate of this. So therefore, we know that dB dt, which is 0.2 meters per second. So because of increasing, so it's positive, okay? Just keep that in mind. And the question is asking for dI dt. So we know that dI dt is equal to, we have dI and then dt here. And it's given in this one here, which is dB dt. So therefore, we just write dB and dB here. So it's given for dB dt already. So we just need to find dI dB. And we know that the formula given is I is equal to 9 over B. So to differentiate this respect to B, so we'll bring this up. This is exactly the same as 9. Bring the B up, so it become negative in the C. So 9B to the power of negative 1. So to differentiate this, so we go dI dB, which is the negative 1, we'll bring it down. So we less 1, so become negative 2 or minus 2 if you like. So negative 9, because 9 times negative 1 is negative 9. And B minus 2. So this is exactly the same as negative 9 over B squared, because we need to bring the negative index down and then become positive index, okay? Now I just substitute this value in. So the dB is we have 9 over B squared. And then we times by dB dt. That is 0.2. There you go. So that will give me, let me just move this up a bit. So that becomes negative 1.8, because 2 times 9 is 18, okay? But 0.2, so 1.8 and B squared. Then we need to find the rate of change for A, that is when A is 12. But then we have B there. So we know that A is equal to 9 over B. So therefore, when A is 12, we need to find the value of B first, okay? So 12 is equal to 9 over B. So let me just move this up. So if I times B on both sides, so this is B. So that cancel out. So that is 12B is equal to 9. I divide by 12. So 9 over 12 is 3/4 or 0.75. Okay, that's what it is. Now I just substitute the value B into the dI dt. So therefore, dI dt is equal to, when I is equal to 12, or B is equal to 0.75. I can just change that. So B equals 0.75. So that will give me minus 1.8 over 0.75 squared. So let's just sort this out. So I just put negative fractions and 1.8 over 0.75 squared. There you go. So negative 3.2. So let me just write this down. So negative 3.2. And don't forget the units, okay? So which is meters per second. Meters per second. There you go. I hope you got it correct. Please pause the video and try this one yourself. Hi, I'm back. How did you go? So let me go through it with you, okay? So first of all, we know that the rate of the radius, okay? The radius is increasing at a rate of this. So that's first thing. So we know that dr dt is equal to 5 centimeters per second. And it's positive because the rate of the radius is increasing, okay? And if it's decreasing, it'll be negative, right? Okay. Now the question is, what is the rate of the area increasing? That is dI dt. So first of all, we know that using chain rule, so dI, so this is dt, and it's given dr dt. So we just use dr. There you go. And this one is already given. So now we just need to find dI dr. And we know that area of a circle, because it said circular ripple. So we know the area of a circle is pi r squared. And then we just differentiate it. So dI dr is the 2, bring it down, become 2 pi, and we less 1, so 2 pi r. So therefore, let me just move this up. So this will give me dI dr is 2 pi r. And then we need to time by the rate of change of the radius, which is 5 dr dt. So that will give me 10 pi r. There you go. But then we need to find the rate of change of the area at r is equal to 15 centimeters. So now we just substitute the radius is equal to 15 centimeters. So we write this down, dI dt at r is 15 centimeters. So I just put that in. So 10 pi times 15. So that will give me 150 pi, because it's 10 times 15 is 150 pi centimeters squared, because it's area, okay, per second. There you go. So the answer should be C. That's the answer. And I hope you got it correct. Thank you so much for watching. Bye.